I would like to solve this question that use total probability theorem and Bayes theorem to solve. A true-false question is to be posed to a father and son team on a quiz show. Both the father and the son will independently give the correct answer with probability Q. They think of the following two strategies to come up with an answer. Strategy 1. Choose one of them uniformly at random and let that person answer the question. What is the probability that the team answers correctly using this strategy? Okay, so now that I want to solve this question, let's define the event. Let C be the event that corresponds to answer correctly. Answer correctly. Let S be the event that corresponds to son answers, and let F be the event that corresponds to father answers. Okay, so what do we know? We choose one of them uniformly at random, one of the father or son. So we know that probability of son answers is 1/2, and it's equal to the probability that the father answers because we choose them uniformly at random, which means 1/2. Then it says that the father and the son will independently give the correct answer with probability Q. What it means that the probability that we have the correct answer given that son answers that question is Q. And also probability that the answer is correct given that the father answers, it's also Q. Okay, so based on this information, we want to find what is the probability that the team answers correctly using this strategy. So we're looking for probability of being correct. Okay, so if I want to kind of give you a review of total probability theorem, we said that if we have a sample space, and if we have the events that partition my sample space, here I have son and father, and then if I have just one arbitrary event that being correct is one of them, then the probability that being correct is equal to the probability that being correct given that son answers the question. So this one would be the probability that being correct given that son answers times the probability that son answers the question, plus this part would be the probability that being correct given that father answers the question. So probability of being correct given that father answers the question times probability that father answers the question. So probability of C given S is Q times probability of S is 1/2 plus probability that is correct given the father answers is Q. Probability of F is also 1/2. So we have 2 times Q over 2, which is Q. So the probability that team answers correctly using this strategy is Q. Strategy 2. Have them both consider the question and then either give the common answer if they agree, or if they disagree, they flip a fair coin to determine which answer to give. What is the probability that the team answers correctly using this strategy? So we want to find the probability of giving the correct answer. Let me draw the sample space now for you So this is the sample space. In this strategy, sample space would be different because now I consider the fact that with this strategy, I consider the fact that they have the common answer or they don't have the common answer. So if their answer match up or if their answer mismatched. Okay, and now I'm looking for the probability of the event C being correct. Okay, so the probability of being correct as the total probability theorem would be the probability of their answer match and it's correct, which basically this blue area. So probability of being correct and means intersection and their answer match up, or which would be plus probability of their answer is correct and they disagree, so mismatch and their each other answers one more time, mismatch. Okay, very good. Now for the mismatch, I have this pink area. These are disconnected or basically disjoint, and so I can add up their probabilities. Okay, now let's figure out the first one. What is the probability that their answer match and it's correct? So in that case, it's easy. It's just because I can say that the son answered the question and his answer is correct, and also the father answers the question and his answer is correct. This is the only case that I have the correct answer, and since the answer match, son and the father they can answer the question, because and the strategy says that if they have the common answer, then either give the common answer. So we don't choose in that case. So probability that the son gives the correct answer, it's given, it's Q. And the probability that the father gives the correct answer, it is Q. Okay, so that one was easy. Now we need to find the probability that they disagree on their answers mismatch, and we want to find the correct answer. Okay, so for this one, I'm gonna use the conditional probability. I'm gonna say that it's probability of being correct given that it's mismatch times the probability that their answer mismatched. Okay, let's try to find this one first. How can I find the probability that their answers mismatch? It means that son has the correct idea and the father has the correct answer, or son has the incorrect answer and the father has the correct answer. So I'm gonna say that the probability that the son gives the correct answer and the father gives the incorrect answer, or the probability that the son gives the incorrect answer and the father has the correct answer. You see, this is the only case, because the other cases would be the son and father both gives the correct answer, which would be in the match part, or both of them gives the incorrect answer, which again would be in the match part. So when they mismatch, I have just these cases. Now let's write the probability for each one. So the son gives the correct answer. The probability that the son gives the correct answer is given as Q. And the probability that the father gives the incorrect answer, which would be 1 minus Q. Plus, the son gives the incorrect answer, which would be 1 minus Q, times the father gives the correct answer Q, and each one of them are independent from each other. That's why we can multiply them together. So this is the probability of mismatch. Now, what is the probability that they give the correct answer given that they mismatch? Okay, so we say that if they disagree, in that case, we just flip a coin to determine which one gives the correct answer. So when they mismatch, exactly one of the father and the son is correct, okay? Because this is this match. So both of them, they don't agree on their answers. So we don't have the situation that both of them gives the correct answer or both of them gives the incorrect answer. We just have the situation that one of them gives the correct answer, and in that case, we just flip a coin. We say the father or the son, each one of them gives the correct answer or incorrect answer. So the probability in here, in this one, is just 1/2. It's just because we determine this probability by just flipping a coin. And that's why it's just 1/2. So let me simplify our answer. So I have Q squared plus 1/2 times, this is 2 times Q times 1 minus Q. So I get Q squared plus Q squared plus Q plus, I'm going to distribute Q in here. So plus Q minus Q squared. So the answer here is also Q. So the probability of being correct in here is also Q. And the strategy 2. Now the question is that which strategy should they take? Actually, as you see in here, in a strategy 1 and in a strategy 2, the probability of gives the correct answer is Q. So since the probability of answering correctly is the same in either strategy, they could use either one. So the answer here would be either one.